So, hi everybody. Just want to show you a few things on Proteus. This is going to be just the intro. So, you find Proteus and you started. Remember, I said I want you to get Proteus 8.4 because that's what I have, as you see. So, first thing I want you to do before you start a new project or anything like that, you're going to go System Settings. And instead of having the library locale being European, you're going to do North American. You're going to say OK. Then you're going to close Proteus and you're going to start it again. You need to do that for this change to come into effect. So that's very important. And then if you want to start a new project, then you just go new project. Oh, there's another thing I wanted you to do. Okay. So sorry about that. One other thing in system settings that could be really fun to have, instead of having the initial documents to be in, so when you save your document, instead of it going into my documents, I suggest you go initial folder is always the following, and you choose a folder that is maybe on your OneDrive. So every time you open a new project, it's directly going to go onto OneDrive. Eventually, maybe we'll get new template folders and new library folders, but we'll look at that another time. So once you change that, again, you will have to shut down and start again. Okay. So that's a few little things that you want to do before you start a new project. So now we're going to start a new project. And see, it's in the place where I set it to be. I'm going to name it Project 2. Doesn't matter. You choose the name. And here we're going to go with Landscape A4. And we're going to say next. Do not create a PCB layout. No firmware projects. Press start, press next, and then finish. And you're going to get a nice sheet of paper. And you will have here a nice header. So remember, step 1 in doing your design, you want to populate this header. So how do we do that? We go to Design and Edit Design Properties. And here you can put a title. So this is Project 2. Document number, that's usually when you're in a company, you have a document number and all of that. The revision, again, it's in a company, you will have a system that you will have to put a revision, a document number. In this case, we're just going to leave them blank. And then you're going to put your name. And you're going to say, okay. And it looks like you didn't change anything, but in fact, once you start touching, it updates. So rev stays like that, the date. The path is there. Maybe eventually maybe we'll work on getting a header that is more customized to us and looks a little bit better. So here we go. So we've done that. Now we can check if there's anything else in sheet properties. That sheet title. Oh, very interesting. Let's see. This is, let's say, page 1. Let's see if it changes anything. Oh, page 1 in front of path. Actually, that's not very nice. So maybe we take that off and don't put anything. It kind of messes up the path. There you go. That's nice. We're going to leave it like that for now. Very good. So that's the first step. Now I'm going to pause for a second. Okay, so I will send you this document. It's a beautiful document. You'll have it also printed once you get your project for soldering. And as I said, this is the project that we're working on. This is what you will be soldering, but this is also what you will be drawing. It's got a nice little pamphlet that explains to you how to solder everything, procedure, and which parts to solder first and which parts to solder afterwards, and the final project soldered, how it looks. It's beautiful documentation, and it even shows you what is a good soldering and what is not a good soldering. So here, there's too little. Remember, we saw today in the class, the solder should go all the way to the edge of the pad. I don't have the part with me right now, but I do suspect this is a double-sided PCB. So the solder should go all the way underneath also. So that would be a small error in their documentation, which often happens. And the fun thing is at the last page is our circuit of our kit. So we're going to turn it around so we see it better. And not that your drawing needs to look exactly like this, but almost. Okay. Remember I said the numbers, the values of the resistances, the name of the resistances need to be the same for the diode. I would just say that this here is probably not required, and you'll see why when we do it on Proteus. So let's go back to our Proteus. So the step number 2 in our PowerPoint was to go get the components. So in order to get the components, we come here to component mode. And once we have here, we go to pick devices, P, and you get a catalog of all the devices possible. So let's start with the easy one, resistance. There you go, resistance, generic resistor, and with the symbol that we like, which is that zigzag, which is the North American image that we use. So what we do is we double click on it. And if you noticed right here, the part was placed in my box that I can use for my image. Okay, what other parts were there? Well, there was a 4017, and there are many of them. A 4017 you will learn with Subash what it is, maybe this semester, maybe next semester. But it is a counter. So give me a moment. I'm just going to verify which one is the good one. So we will take the first one. So again, we double click on it and 4017 goes into our box. A few interesting things to see here is the PCB layout. So that's how it would look. This would be important if you were designing your PCB. So you would want a PCB layout that matches. Not that it's mandatory because you can change that later on. And this is the schematic model that it's going to look like. So it's not going to look exactly like the schematic that we saw because our image, it looks a bit different. One thing is important to notice: if you want to simulate your schematic, you need to have a model here. For example, over here, it's got almost the same footprint. It looks almost the same, but it says no simulator model. So that would mean that if you simulate with this part, it will not work. Okay, so the next part we would need is an NE 555. So analog, there's a schematic model, we double click. We also need a capacitor. And there are many, but we have one here. Let's choose it. Very good. What else do we need? We need an LED. So in the LEDs, you see you have lots and lots of them. So we want a model optoelectronics. And we want an active one. Why do we want an active one? Because it's actually going to flash and we're going to see it while we are in simulation mode, which is fun to see, right? Not the B-colored ones. Okay, so right, it's these animated LED model, blue, green, red, or yellow. I don't remember, but I think one of them was harder to see. I'm gonna go with blue. You can go with any of them. Double click. We have our LED blue, and we also need a potentiometer. It's okay if you don't know what it is. I'll try to explain the parts as we go along, maybe in the lab. But for now, let's just learn how to design this. So the pot, I actually know from experience that it's called HG. Oh, it's pot HG. And again, it's an active part. So we're going to be able to move it around in the simulation. And it's going to let us, and it's going to affect our circuit. So we double click, and I think I've got all the parts. If not, we can always add more parts. That's no problem. So we say, okay. So what do we want to do now is we click on a part, then we come to the drawing, we click, and we place our part. And we click on a capacitor, and we click once, and let's wait. Let's not click a second time. It's in pink. Well, at least it looks pink to me. If I press on the plus sign, all of a sudden my part moves and my part rotates. So then I can place it already the way I want. If I remember well, and let me check, we have two capacitors that we need. So I'm going to place both, C1, C2. You noticed that the first capacitor that you put on is called C1, and you click again, C2. If you clicked again, you would get C3, C4. I don't need all of them, so I'm gonna drag and drop to select both, and I'm just going to delete them. No problem. Then the LEDs. Okay, how many do I need? I actually need 20 of them. And it's funny, yeah, it's D1 all the way to D10, and then D11 all the way to D20. So let's go back to our Proteus, and we're going to click, and look, it's pointing not the right way. So 1, 2, and then it's right there. So D1, D2, 3, D4. You're getting the picture. You know how to do the rest. I'm not going to do all of them. We're just going to waste time. NE555. Oh, it looks very different than the NE555 we have there. So I'm not going to rotate it right now. I'm just going to put it down. And you see the names U1, U2. They're not the same names as are on here. Here you have, let's see, it looks like a J, JC2G1. And the other one is IC1. It doesn't look quite the same. So our drawing is not going to look quite the same as this one does. That's okay, as long as it is accurate, that all the lines go to the right place, all the connections are connected to the right place. Okay, so that's important. Then we have a whole bunch of resistances. We might turn the NE555, we'll see. So R1 is over here. Then we have R12 over here, which is the HG, the potentiometer. And then we have R2 to R11, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and R12 over here. So you can, if you think of it, you know, grab the resistors, and while there was one around here, I'll move it around afterwards. And then I had plus sign, and then I had R2, R3, R4, and so on and so forth. Let's say you didn't think of it, and then you pick the pot, the potentiometer, and I think it was this way. It doesn't matter, we can move it, and you put it down, and it says RV1. It's supposed to be R12, right? So we can either double click on RV1, and we're going to get the change to Shift R12, and we say okay. You can also double click on it, and then you get the part, the reference, so that's the name, and the value. Oh, what was the value? It's 50K. Ah, very interesting. So we leave the K there. We can just put 50. We say okay. And we're ready with this resistor. We can do the same thing with this one. What was the value? I didn't record. So that's 15K. And look, it's above the other one. So let's put it there right now. So it's R1 and 15K, right? If I didn't make a mistake. Okay, and to move it, you actually pick it and you move it. Once it's highlighted in red, you can press on the plus button and it rotates. You can grab this one. Actually, the pot is a lot harder to move. So you want to select it first and then move it. Because it is a active part and you can change its value, it's actually harder to move. I don't know why. Whoops. So I just priced another one. I don't want it. See how it changes? Haha. I'm going to select it again. And I'm going to delete that one because I don't need it. So I think I've shown you how to put every piece there. Let me re-verify that we are not missing anything. HG pot, capacitor. Oh, I forgot VCC and ground. See, these are not the images that I asked you to use. So we will use the ones that I've asked you to use. So VCC will look different, and this one would look different also, which is a ground. Here, J1, we're not going to draw it. We're going to leave it aside. So we have the NE555, the CD 4017, although it doesn't say CD, that's fine. The ground is over there. See, again, they have a weird way of putting ground. I don't want you to do that. And the two capacitors, I think we've got everything. Good. So from now, what you need to do is you need to connect everything. And how do you connect stuff? So let me see. I'm going to bring this one a little bit further. And I'm going to hover over the resistor. And you see there's a little red dot that highlights. So I'm going to left click. And then when I move away, there's a wire that leaves with me. So if I go by memory, I think I got to go to pin 7. So here I'm just going to, like, if you move around, it actually follows you and it wants to connect. Sometimes it doesn't go exactly the way you want to go, like this makes sense, no. So sometimes what you want to do is, oh, I want to bring it all the way up here because I find it prettier. So you can click once and that kind of forces the wire to stay there. And then you can bring it to 7. Okay, let's go check. Did I remember well? Oh, no, see, I didn't remember well. The top of the resistor went to pin 8 and pin 4. But that dot, we don't want it connected to that pin. It looks very awful. Okay, let's go back. So we're going to go with our select tool. I'm going to select that line and we're going to delete it because that's not where we want to go. Again, red dot, we want to go to pin 8. Oh my God, I don't see anything. Pin 8. Oh, there you go, pin 8. See, right now I'm realizing that I really want this chip to have pin 8 up because that's VCC. Right now I put ground up, bad idea, VCC going up. Okay, select, click because I want it here, and pin 8. It was also connected to pin 4, I think. Let's go back and check. Yes, it's also connected to pin 4. So what I'm going to do, I'm going to hover over pin 4 and I'm going to come over here. I'm going to click and you see that dot? A dot comes in by itself. You don't need to do that. So that looks beautiful. I'm going to let you do the rest of the connections. Actually, what I'm going to do is I'm going to pause so you don't see me doing all of this. And so I've gotten a little bit further along, not much. I'm not going to do the full drawing right now. So I'm going to bring in these two terminals so you see where they are. They're right here, terminals. And I have the default, the input, the output, bidirectional, power, ground, chassis bus, power. I'm going to bring the power in. I'm going to put it above. And we're going to connect it. That's a habit. I always put it so for me it crosses. It's better if it doesn't. Ground. And you see it's already in the direction we want. So we're going to put it right there. Awesome. A few things. let's move this resistor. Let's move this ground a little bit. Move it like this, have a little bit more space. I'm getting really close over here, so maybe I'll select the whole thing, move it over. That kind of thing, you kind of look at it at the end. C1 is a 1 microfarad and not a nanofarad like it is here. This is a capital letter and it should be a capital letter. They have a little letter, that's fine. But for us, it needs to stay a capital. We double click on it. And instead of an N, we put a U. We don't have the mu, it's okay. And I think we've got everything. Oh, no. In order to do this in Proteus, it's a little bit different. So this is just putting the ground connection to the chip and putting VCC to VCC. VCC is power. So let's look at it. Here, what we're going to do, I'm going to double click. I'm going to see if I have VCC. I have VCC right there. I'm going to say okay. And on this chip, so I right clicked and you can edit properties or double click on it. And hidden pins. So VDD is VDD, VSS is VSS. So that's fine, it's good. The pins are hidden. They don't show them, it would be too crowded. But what that means is that power is connected and ground is connected to this chip. Okay, so we press OK. We're going to look on it, look at the drawing again. Oh, that's not what I wanted to do right here. So one last thing I'll do is to move around. It's a funny thing. So right now I just put another, I just did Control Z to undo the grounds that I put in. To move around, yes, you can zoom in and out sometimes with your, I have a pad on my laptop. So with your mouse, if you have a wheel, you can scroll up and down and you'll zoom in and out. You have here zooms. So zoom to view the entire sheet. Pretty cool. Zoom plus, zoom minus. Maybe you want to zoom to a specific area that you want to zoom to. And you have this one here, which is a little funny to use. You can move it around wherever you want, but then you have to click again. Okay. So what we'll do over here is that I will connect just a few of them. I'm missing a few. That's right. That's why it doesn't look right. And I'm going to bring this ground over here. So I'm just going really fast. I'm just showing you some of the steps. I'm not showing you all the steps. Connect over here. This one goes to where? Very interesting. Let's go check it out. It won't let me. So escape. To the other drawing. So we're looking at D3R5. Oh, see, already I made a mistake. So D3 to R4. No, I didn't make a mistake. Sorry. So it was right. So R4 connects to pin 4. Okay. R4 connects to pin 4. Okay. So I'm going to let you figure this out. You want to make it neat. You want to have all the values correct. So I'm sure this is not a 10K. It's much smaller, but in the right values. And eventually, maybe I'll make another video to show you how to simulate this. Okay, so that's it for today. I hope you get to do the full drawing in the lab.